before lunch on Saturday. That's
Even the teacher is like, no.
I don't know yet. If doctors say, oh, come 9 o'clock. If doctors say, oh, the appointment is 12 o'clock. Because this is an appointment I've been trying to make with this guy for like 2 weeks.
And he still isn't giving you a time?
No. He might have put it in the message. Maybe I can't remember. But I remember we agreed on 9th of May. And that was like 2 weeks ago. It's like, oh, we can only meet in May. I'm been booked. Something like that. It's a dentist, by the way. So I'm not pregnant, so don't think I'm pregnant. I'm not pregnant. This is food, not baby. Alright. So let's move on. So with this, you should be able to solve the questions. We've only done question 3. There are 1 to 6 questions on that page, so you can, walk around the rest. Yeah? Let's take one more, which is after the example given. From question 7 to 9, let's pick a question. 7 to 9. Of course, 9 seems long because of our time, but if that's what we want to pick, well, there's nothing we can do about that. Can somebody pick from 7 to 9 one first? 8. Alright. You sure? You don't know. She doesn't even know. She just said 8. It's also cubic. Alright, that's no problem. Because it's cubic, at least one of the 0 is purely imaginary. But we also know that at least one of the 0 should be what? It should have at least 1 0. Oh, okay. We already know it has a 0. So at least one of them is purely imaginary. Then at least one of them should be real too, basically. Anyways, let's do 8. I take this place off. This one maybe. Mr. Chen, want to take a picture of us? Let's do it together. Let's read through the question while I get the board ready. Yes, ma'am. Oh, yeah. What happened?
No, just
Are you taking the picture, sir? You want to move closer because we want to get the exact picture.
That's good.
Good? Everything? Or just this side? What do you mean both? There are 3 parts of the board.
One board?
Okay. Discuss this. Let's hear your view before we begin. I have an investigation prepared. So even if we are not able to meet, please send me the investigation by weekend. Okay? Question 8. At least one of the zeros of p of x, so let's write that polynomial. P of x is x cubed, no, 3x cubed. I didn't get enough sleep. The new camera girl, are we here? Okay. 3x cubed plus kx squared plus 15x plus 10. K is said to be a real number. At least one of the roots is purely imaginary. Find k and n's factorize that. At least one is purely imaginary. So what does that tell us? the purely imaginary 0 be, let's say, mi. You know what purely imaginary means, right? It means a is 0. Okay? So you have something like this. If you have a plus bi, if it is real, b is equal to 0. If it is purely imaginary, a is equal to 0. But this is the general form. Okay? So if it is purely imaginary, then let it be that. Okay? So do we know another root? Another 0, sorry? Negative bi, that's the conjugate. Right? Which implies that its conjugate is also a 0. That is negative mi. Understood? So the sum of this mi minus mi is equal to 0. The product of these zeros, mi times negative mi, which is negative m squared I squared. Do you agree that is positive m squared? Agree? Which implies the quadratic factor, of course the irreducible one. We don't need to do the word irreducible like I said earlier. The quadratic factor becomes x squared minus sum 0 plus product m squared, so which will be x squared plus n squared. So that's the quadratic factor. Comprehending? Now, the last one, we have no information about it. So we're going to assume it's a linear ax plus b, sort of. But there's something here. Look, everybody, please pay attention. Pay attention. Which implies our p of x is, remember, 3x cubed plus kx squared plus 15x plus 10 will be your x squared plus 10 plus m squared, right? Then, now we need the coefficients to be 3. I need your attention, please. We need the coefficient of cube to be 3. It means this must be some 3x. We need the constant to be 10. Then this must be some 10 over m squared. So that when the constant multiplies, you get 10. Let me do that again. Do you understand what I did there? Yeah. So I do that again. So this implies that p of x equals, which is equal to 3x squared, x cubed, sorry, plus kx squared, plus 15x plus 10 can actually be factored into x squared plus m squared. So I go with that again, I go over that again. Please listen if you are confused. For the linear part, it should be something ax plus b, right? For the linear part. However, the product of this and this determines the first term. So if this must be 3, then this must contain some 3. That we know. Also, the product of the constant here and the constant here gives 10. So basically, the product of m squared and the unknown constant must give 10. So that unknown constant must be 10 divided by m squared. That's how I got the fraction. So this must be 10 over m squared. So we're going to expand this, then draw a comparison. If we expand, what do we have? X cubed. Yes? No, 3x cubed actually. Right? Quickly. The other one. 10 over m squared x squared. Right? Then this times this will be plus 3m squared x. And this will be plus 10. There's something wrong. There is no x term.
There
Oh,
is.
there's x
There
term.
is. There is.
Cube squared x constant. Good. So here we can get our m. Okay? What is that? We can bring equation from the square can help us out. Actually, the square cannot because there are two unknowns. However, this can help us out. This one, right? Can help us out. So from here now. Sorry. Checking the time, trying not to be too late because I know there are foodies here. Like, let's see where you expect foodie for today. Karen again. Leo said it, not me. I said there are foodies here, like people who can't wait to eat, and they said, yes, it is. It's like this is a constant, we know. Okay, so when you compare, what do we have? We have 10 over m squared equals k. That's one equation, which we can't use for now. We also have 3m squared equals 15. Please confirm. So from here, m squared is equal to 5. M is plus or minus square root of 5. Okay? And if that is the case, then our k, which is equal to 10 over m squared, whether plus or minus, k remains the same. Agree?
Yes.
Why?
Because a negative number squared will be.
Because of the square. So I don't need to work it out twice. Otherwise, we'll do positive, negative if it wasn't for the square. And we might end up getting minus or plus. Alright? But in this case, we don't have to. So 10 over, so if I write plus or minus square root of 5 squared, I think that's 10 over 5 is equal to 2. Okay? So what exactly is the question? Let's see the language of the question. Find k. K is equal to 2.
Hence factorize
X factorize px into product of linear factors. Okay. So px, p of x